Our next talk here for 10:30, which is almost up, I suppose we could start it now, is Tom Charlesworth, Willy Byte, and the Infinite IRQ Investigation, talking about a subtle bug in a game, Willy Byte in the Digital Dimension from 1984. So you want to cue that up?
Good morning everyone, I'm Tom Charlesworth and I'll be spending the next 15 minutes describing a curious latent bug in the Willy Byte game. Over the past 20 years of emulator development, I've come across all manner of interesting bugs, but this one is a particular standout for me. So, this morning, let me share with you all of the gory details. Before I dig into the details of the bug, here's a quick overview of AppleWin. AppleWin emulates 8-bit machines from the Apple II line, along with some clones. It's been in open source development right from the beginning, currently residing in GitHub. I'm the lead. Contributions from Michael and Nick, but also many more. It's Windows only, but others have forked it for other OSs. In terms of unique selling points, it's got a simple out-of-the-box experience. Just unzip it and go. It's got a great built-in debugger. For example, it includes symbolic address resolution, instruction traces, beam positions. The list goes on. It has support for all the detail in French touch demos, for cycle accuracy for beam racing. And its Mockingboard support includes simple SSI 263 speech chip emulation.
Prepare to enter the digital dimension.
So I won't be going into the details of all of this, but at a high level, Mockingboard is the sound card for the Apple II series. For the purpose of this talk, there's a 6522 interface chip and an SSI 263 speech chip, both of which are capable of generating interrupts to the 6502. Okay, so here's where it started for me in 2007. After a report in comp.emulators.apple2. So in terms of emulation, when a Mockingboard without a speech chip is in the emulated machine, the game runs absolutely fine, as it does on real hardware. But when I include a Mockingboard with the speech chip, then this is when I have some issues. In a nutshell, the emulation bug is simply that the game works without the speech chip, but hangs with the speech chip installed. Okay, so let's drill down a level and walk through some of the details. The game boots, and the intro sequence starts.
Willy Byte in the digital dimension.
The speech chip plays back this phrase, then a classic Mockingboard tune plays at 60 Hz using the peripheral chip running in periodic mode to generate an interrupt, and this drives the programmable sound generator, the AY8913. Press any key to exit the intro sequence, then flip over the disc.
Prepare to enter the digital dimension.
So at this point, the speech chip should say this second phrase, but instead, on enabling 6502 interrupts using the CLI opcode, it gets stuck with infinite timer 1 interrupts. Now, the timer 1 interrupt comes from exiting the tune, but the code not clearing the timer 1 interrupt flag. So specifically, the code executes SIE opcode, which disables interrupts to the 6502. Then, this code here sets the timer 1 to one-shot mode, and some cycles later the timer 1 will underflow and the 6522 will now be asserting IRQ. But remember, from this opcode up here, interrupts to the 6502 are still disabled, so the interrupt from timer 1 is only pending. And then later, when the second speech phrase is queued up, the code will execute a CLI which enables interrupts to the 6502, at which point the pending interrupt, timer 1 interrupt from the 6522, can now be taken by the 6502. But the interrupt handler assumes a speech interrupt, not an interrupt from the timer 1, so it only clears the 6522 speech interrupt flag. And then, on executing RTI, that is, return from interrupt, the interrupt fires again, infinitely. My emulation fix for a long time before I got access to real Mockingboard hardware was, when the 6522 timer 1 was in one-shot mode, on the initial underflow it would assert the interrupt as expected, but then on a second underflow it would deassert the interrupt, which seemed pretty reasonable, and it fixed the Willy Byte issue, and that was the fix for many years. But when I eventually tested on real hardware, I found there was no deassert. In order to explain this Willy Byte latent bug, first of all we need to understand a bit of nuanced behaviour of the 6502. So from Jim Sather's Understanding the Apple IIe, we can see that for the opcode store absolute with X index, on the fourth cycle, shown here in yellow, there was a false read of absolute address plus X. Put another way, the first cycle does the opcode fetch, then the second and third fetch the low and high bytes of the address respectively. On the fourth cycle it does the false read of absolute address plus the X register, and then finally on the fifth cycle it will do the write to address plus X. Now this false read is well understood, and Woz himself even exploits it in the DIS2 logical state sequence interface with the 6502. It's harmless for regular memory accesses, but care needs to be taken when used with I/O memory. Another key point that we need to understand in order to make sense of this Willy Byte issue is the subtlety of the Mockingboard memory map. The 6522 is selected when address line 7 is low, meaning any address in the low 128 bytes. This chip mapping is repeated every 16 bytes due to the 4 address line decode. The speech chip is selected when address line 6 is high, so from CN40 for 64 bytes, and this is repeated every 8 bytes due to the 3 address line decode. From the chip select logic, you can see that both chips get selected at CN40. So here we've got a simplified version of the memory map, where n is the slot number, and again you can see mapped in at CN40 not only have we got the speech chip, but also its 5 registers, and also the peripheral chip as well. So what registers does the speech chip write actually stomp on? Well, the first 4 registers aren't interesting. These are just ports A and B and their direction bits. And then register 4. This is just timer 1 low, and writes to it aren't interesting either. But what about reads? But reads from the timer 1 count, now they're interesting because they clear the timer 1 interrupt. Let's take a look at the interrupt service handler for the speech playback, see what it does. So we've got the real 6502 code on the right hand side, and on the left is a bit of pseudocode which explains what it does. So in a loop from 4 down to 0, it reads the speech chip data and then writes it to the 5 speech registers, starting at register 4 and running down to 0. But recall from Sather that a store absolute X will do a false read of the absolute address plus the X register, and store absolute plus X to CN44 will also false read, then write to CN04, which will clear the interrupt. Now let's take a moment to recap this. Store absolute plus X to CN44 of our speech chip will do a false read to register 4 of our peripheral chip and clear an interrupt. Generalized, a write to chip B clears an interrupt on chip A. And specifically, it's not the opcode's write, but actually it's false read which is clearing this interrupt. Putting it all together, here's what happens. So the intro tune's playing on the intro sequence via the timer 1 periodic interrupt. Press any key to start the game, at which point interrupts are disabled on the 6502, but timer 1 underflows in one-shot mode, and we have a pending 6522 timer 1 interrupt. Turn over the disk, enter difficulty level, and a second speech phrase is queued up. The code enables 6502 interrupts via the CLI opcode, and immediately the pending timer 1 interrupt interrupts to the 6502. The interrupt service handler for the speech chip is executed and does a store absolute plus X, where address equals CN44. This in turn does an accidental false read from the timer 1 low register on the 6522, which clears the timer 1 interrupt. There's no more timer 1 interrupts, and the speech phrase completes correctly. Okay, so let's wrap all of this up. On the emulator side, it wasn't supporting Mockingboard speech chip writes and duplicating them to the peripheral chip. And also it wasn't supporting store absolute plus X false reads. And on the Willy Byte side, immediately on exiting the intro tune, we got this curious code. Why was it writing 2 to the interrupt enable register? Doesn't make any sense. Surely it should be 40, where 40 means clear timer 1 enable. There's also the speech interrupt service routine, which isn't checking the interrupt source, and so assumes the timer 1 interrupt is actually a speech interrupt. If this were more robust, then the bug would have been found during development. So unknowingly, the game was relying on a false read to an unrelated chip to clear an unexpected interrupt to run correctly. Well, hopefully you can see why this stumped me for so long, and you all agree what a delightfully subtle 36-year-old bug this is.
All right, and we have Tom here to tell us more about this.
Yes. Hi Steve, I'm here.
So we have a question about, does AppleWin have any features that help debugging code with interrupts?
So currently, no. There's nothing in there. Although it is something that I've considered. I mean, obviously, from this sort of extreme case that I've just presented here, it certainly would make sense. And also, there's a lot more demos and applications these days that are making use of some of these interrupt sources from Mockingboard and other cards as well. So, you know, clearly it's something that you know, we could look at.
But this was something that really was only affected something with an emulator. It worked fine on the real hardware in all cases, right?
Correct. Yeah. And I was during when I'd fixed this, or thought I'd fixed it, I was convinced that it was just undocumented behaviour from the 6522. I mean, I pored over the data sheet and I couldn't see anything in there. But to me, as I explained, it sort of made sense that a second. It's a bit complicated, but the timers can run in two modes. One's periodic, so just at the interval that you specify. For instance, 60 hertz, it just repeats every 60 hertz. It generates an interrupt. And in your interrupt service routine, you clear the interrupt. So this is what Vince will be using for his Mockingboard tune that he played at the start of Mist. But there's also this one-shot mode where you can just set the timer interval, and then it will count down to 0 and then underflow and generate a single interrupt. And then after that, the timer will continue to run, but there won't be any more interrupts. And what we could see here in this game was that for some reason the game was setting it to one-shot mode, presumably thinking that it would disable the interrupt by doing that. counting down, and then the interrupt was firing, but it was never clearing that pending interrupt.
We have 1 minute left now. If you have anything else you want to finish up with. Okay. Well, that was a great bit of sleuthing, and I appreciate you sharing that with us.